Hi. Oh, it's so nice. It's great to see you all. It's so nice to be at an in-person RailsConf. God, COVID was hard. So before we get started, I want to give just a brief warning. I'm going to talk about some difficult stuff today, specifically about a natural disaster that affected my family. It'll be gentle, but I figured I'd mention it. So yeah. So in the summer of 2020, my wife and I and our dog moved into the home that we thought we were going to raise our family in. Like a lot of us in the industry, I would say that I lived a really comfortable life. Some might call it a life of privilege. You know, we had very little to worry about. That all changed about a year and a half after this photo was taken. We were on a road trip to San Diego, playing fetch with our dog as the sun set in San Diego. And we got into the car to drive home. And we got a text message to evacuate our house back in Colorado. This is right around 3 o'clock in the afternoon. A couple minutes later, I got some notifications from our security system at home that there was ash falling in front of our house. I checked my phone. I had an air quality monitor in my house. And things were not looking good. This particular measurement, which is a PM 2.5, for those of you who are unfamiliar with air quality, this is kind of like a general common measurement. This number is worse than the worst measurement ever recorded in Beijing, and this is in my home office. About an hour later, I saw this picture on Twitter. This is 100 yards from my house. But we never saw any pictures from inside our neighborhood, at least during the fire. But the following morning, I pulled open Twitter, and there was a video, and this is what our neighborhood looked like. Over 100 homes burned to the ground. Ours is kind of in the top right corner here. In our area alone, there were 1,000 homes that were lost that day. It took a few days before my wife and I could see it for ourselves. This is us in front of our foundation at that point. So one memory that really sticks out to me is realizing 2 weeks after this that I hadn't walked my dog since the fire. Literally something that I had done 3 or 4 days beforehand, I hadn't even thought of doing for 2 weeks. And I noticed other things too. It was really hard for me to focus on anything, and I got really angry really easily. Something else that was really difficult is that technology I used on a regular basis before no longer worked for me. I remember in particular having a really hard time solving image captchas. I got really angry, like, having to click on what picture was a bus. And I had similar struggles with 1Password too. I remember it being really hard to just remember how to use 1Password. What I soon learned from someone at the Red Cross who was helping a lot of us fire victims out was that this kind of significant trauma can actually cause brain damage. And in my case, that damage was both temporary and, as I'm finding out now, permanent. So this experience really opened my eyes to that privilege I had before I went through this experience. It really changed the way I viewed the world more than anything else in my life up to this point. So that's what I'm going to talk about today. Specifically, I'm going to talk about accessibility, which has many definitions. The one I like is from the Interaction Design Foundation, which is that accessibility is the concept of whether a product or service can be used by everyone, however they encounter it. So in the past, I imagined that people with disabilities were mostly just those using wheelchairs or blind people using canes. But I've since learned how disabilities come in many different forms. And one framework we use to describe this is situational, temporary, and permanent. So for example, a permanent touch disability might be having one arm. A temporary touch disability could be having a broken arm. And a situational touch disability could be, holding a baby, or even just holding a door open for someone while you walk into a building. For hearing, a permanent disability is deafness. Temporary might be an ear infection, and situational could be working in a loud environment, like if you're a bartender. So when I couldn't complete these CAPTCHAs, what I had was a temporary cognitive disability. I'm now able to complete them again. But it took a while. It was a month or two before I was able to reliably complete these. So there are various guidelines and standards for accessibility. The WCAG, Section 508, APG. Just know that they don't even all agree with each other. But in practice, for the work that we do in accessibility, what it means is that our applications work with assistive technology. And I won't go into a ton of detail on all the numerous forms of assistive technology. We mainly focus on screen readers, which are tools that read the screen out loud via keyboard control. So for example, when a screen reader looks at this GitHub profile page, VoiceOver announces each section of the page as the user navigates with keyboard navigation. So effectively, screen readers turn web pages into a tree structure that's navigated with the keyboard. And what's great is that as of a recent Chrome release, you can actually view this tree structure that is navigated by screen readers in the Chrome Dev Tools under accessibility. If there's one thing you write down from today's talk, it's that this tool is amazing and will get you a long way to knowing how accessible your application is. So today I'm going to share how we're taking this approach to improve the experience of using GitHub for users of assistive technology like screen readers. We do it using automated scanning, a custom form builder, and what we're calling preview-driven development. But first, hi, my name is Joel. I'm a staff engineer at GitHub. I work on various company-wide UI-related initiatives like accessibility. I'm kind of like a UI architect of sorts for the company. So when I share details of what it's like to work at GitHub, I like to start by giving a rough idea of the scale of the company, because I know that we're all working in companies of very different sizes, and I think it helps you understand where what I'm talking about may or may not apply, or may apply differently in your situation. So as of December, we have about 4,000 employees. GitHub, to this day, is a monolithic Ruby on Rails application. I say that every year, and I think I'm going to be saying that for a while. That's at least when it comes to serving our customer-facing traffic. To give you an idea, we have about 1,400 controllers in our code base. It's actually 1,435, so this has gone up since I made this slide. That's 25% more controllers than we had when I gave a talk at RailsConf last year, which is wild. I love mentioning this stat every year because it really shows how much we continue to invest in our Ruby on Rails monolith, even this many years later. To give you an idea, that 25% was 350 controllers in 1 year. I've worked on a ton of Rails apps that never made it to 350 controllers, and that's just 1 year of GitHub getting bigger. And it's a 15-year-old code base too, right? So we're adding 350 controllers 15 years into building this app, which is mind-blowing. And of course, to do that, we need millions of lines of Ruby. This is another example that's showing our growth. This is the number of lines of ERB in our code base over time. So this is starting in day one, commit number 1, sometime in, it was actually late 2007. Growing to, I think we're pushing 400,000 here, sometime in the middle of the year. You can see that curve is actually kind of, linear and going up. I think it's important to share this kind of context, though, because it can frame why we make some of the decisions that I'm going to talk about today, and why what I'm sharing may be more or less relevant, depending on where you guys are at on that curve in your applications. So another thing that I think is important that I haven't talked about before is maybe some cultural context on what GitHub is like as a company and how that might affect some of the things that we do from an engineering standpoint. I think it's really important to share a little bit of our history because GitHub is kind of a weird company. So for the first 6 years GitHub existed, we had no managers. Does anyone here work at a managerless company at this point? One person? Okay, so I think that fad is pretty much dead at this point, but I think it was a big fad at the time. When you went to our offices in San Francisco, this is actually the entrance to the office, which is a full-scale replica of the Oval Office from the White House. This is No longer the case, but this was at the time. And on the floor, there was a rug that read, "The United Meritocracy of GitHub." So for years, we operated in what some people called a cooking for chefs mindset. We were developers. We knew what we wanted GitHub to be, so we really didn't need to ask anyone what it should be. This meant that we could build whatever sounded good to us and reasonably expect that our customers would agree, right? I don't think that the no managers approach would have worked for as many years as it did if that wasn't the case. It's worth noting that I think we, 6 years with no managers? I think we went 9 years with no product managers, which was equally wild. But as you might imagine, having no managers has its downsides, as evidenced by the fact that only one person raised their hand when I asked that question a couple minutes ago. I know of cases where we basically just ignored straight up requirements from customers because we couldn't even convince anyone in the company to work on them. And this was costing us sales. But thankfully, a lot has changed since then. Today, one of our core company tenets, and we have a cool diagram of different characters to illustrate this, is that we want to be the home for all developers, no matter who they are. So when it comes to accessibility, our goal then is pretty simple: full and equal participation for people with disabilities in the development process. This is what we just recently published as a company, saying that we believe people with disabilities should benefit from and be able to contribute to the creation of human progress. I think that y'all know better than most people that software is driving the future of the world, and we believe that people with disabilities should be able to be part of that human progress. We also believe that access to technology is a fundamental human right, that everyone deserves to have the opportunity to create, innovate, and collaborate while contributing to the future. So these are big goals, especially for a surface area of thousands of unique user-facing pages. I think we have 2,000 unique screens in our app. And because of the scale and how quickly our products are growing, manually and checking and fixing each of these pages for accessibility issues is basically impossible for us. And even if we went that route, you could imagine we'd fix a page and then 6 months later it might regress, right? So to achieve our goals, we really need some good tools. And one of those is automated accessibility scanning. So if you take nothing else away from this talk, besides what I said you should take away earlier, is that bad accessibility almost never breaks CI. Very rarely do any of our standard practices that we have as an industry lead to accessible experiences. So even when we do have automated accessibility checks, they're far from perfect. Know that depending on who you ask, between 30 and 50% of the classes of accessibility issues can be caught with automation. So in terms of the kind of accessibility problems, you're looking at, in the most optimistic sense, 50%. I would say I'm probably in the belief that it's actually lower than 30 based on the work I've done. So just for example here, we can have an accessibility check of some sort. The images have alt text, right? You could do this with a couple different approaches with linters. But we can't actually check that the alternative text correctly describes the image. So for example here, we have alt text that says a cat sitting on a rock, but the picture is of a dog. So while there is alt text to someone who is visually impaired and is relying on it to interpret this image, it's actually being interpreted incorrectly. So there's some more subtle issues too. Designers use a ton of techniques that are generally referred to as Gestalt techniques. One of them is proximity, and that is using the grouping of items or the proximity items have to one another to imply meaning. So for example here, we have a grid on one side and 2 columns on the other. Now, that's something that is visual and implies relationships to those of us who are sighted, but to someone who's visually impaired, they don't get that information, at least by default. So that being said, automated scanning can be pretty useful, and the most common tool that's used in the industry is called Axe. Axe can be run a couple different ways. It can be run as a browser plugin, and you can view violations basically in your dev tools. This is the most common way. But the most effective thing we've done is we just embed it in the page, and we turn it on for whenever a staff member is running our application. And basically what it does is it highlights any accessibility issues in red on the page, and it logs them as console errors in development. We also enable this as a bundle that staff members can turn on when they're using the app in production, which is really great. We also use it in our end-to-end browser test suite that runs against every production deploy. It's built in Playwright, and we have our check accessibility hook, which basically just runs Axe every time a page changes. And then if there are any Axe errors, we just fail the build. We also write some custom Axe rules. So this is really helpful because we have some patterns that are in our application that we know are inaccessible, but Axe by default won't catch. So for example, you might know that, say you hover over a button in GitHub, on GitHub, and you have a tooltip, like one of the little black things that pop up over the button to tell you more about it. Well, it turns out if you put a link in there, it's really bad for accessibility. So this linter, it will literally say, if the linter contains anything besides text, just fail the build. But a big problem we've run into as we roll out Axe across our application is intractability. So in some cases, we run into UI patterns that simply weren't accessible in any way, sometimes to the point of needing to rethink an entire workflow in the application, not just one page, but how multiple pages connect together. Other things like drag and drop are especially difficult. So you can think about here's GitHub projects, right? Can you think of how you would take a card and prioritize it if you were just using your keyboard right now? How would you take in the first column, the fourth card and put it in the first position? It's possible to make this UI accessible, but as you might imagine, it'd be really hard to write a linter that would tell you that as a problem. So despite all those downsides, Axe is a really great starting point. Making your app what we call Axe clean, basically having all of your screens pass Axe, is really significant and would put you in probably the 90th percentile of accessibility just by doing that. So what we do is we generally start by trying to make a page Axe clean before doing some of the more labor-intensive work, because it can often start to reveal where some of those more fundamental intractable problems are. So another critical tool in our accessibility work has been creating a custom forms framework. So, as many of you probably know, forms are basically the core competency of Rails. If you go back to the original Build a Blog YouTube video from DHH from, I think it was 17 or 18 years ago now, most of the demo is him building forms. And 15 years later, he made another demo for Hotwire, and it's still mostly building forms. So this is obviously something that Rails should be really good at, right? Core competency kinds of things. And it is, Rails has really great built-in form helpers. We have form tag and form for, I think form with now, which is actually the first two combined. So if we look at this example, this is from the form helpers guides. What this example makes really painfully obvious is that form with is basically just a one-to-one mapping with what comes out in the DOM. It does add, I think, the CSRF tag, which is actually what I believe is the most killer feature in Rails. But effectively, it's a DSL for DOM nodes, right? And this is great. It simplifies a ton of complexity around building forms correctly, and it gives us, this syntactic sugar for things like select options and whatnot. But it is not accessible right out of the box. So if we look at this example code, you can see that the form input has an associated label. And this was generated by two separate method calls. You see we call form.label and form.textfield. And this example is great because it actually is accessible. This specifically passes Axe rule 4.4, which is that form element input elements must have labels. And here's the full text of it, and I will read it. Axe rule 4.4 says, programmatically associate labels with all form controls. The recommended method is to use the label element in an explicit association using the for and ID attributes. Literally, if you violate 4.4, this is the text I think that it shows you. And our example code does this correctly, but there's a problem. It's not easy to remember to do this. As the Axe rule states, all of our form controls need to have labels, and I'm of the belief that there should be no exception to that rule. Yeah, and in Rails, this is kind of something you just have to happen to know to do. So one of my favorite software engineering books is called A Philosophy of Software Design. I think this is actually one of the best books in kind of the software engineering philosophy canon. Love that cover, right? Spaghetti turning into cleaner lines. So while working on this problem of making our forms accessible, I was reminded of maybe one of the better chapters in the book, which is titled Define Errors Out of Existence. And the premise really is just that. You probably don't really need to read the chapter, but we should construct our software to make invalid states impossible. So about a year ago, we realized that we needed to do this for how we build forms. I mean, like I said, GitHub has 2,000 pages. A lot of them have forms on them. And luckily for me, we had just hired a new engineer on our team, and he was really eager for a fun problem to solve. So I asked him, what would it take to make the way we build forms at GitHub accessible by default, hence the title of the talk. And that's where our custom forms framework was born. Cameron set off to architect a form builder that avoided a lot of common accessibility bugs. So if we take our previous example and rewrite it in our new DSL, the most important thing to highlight here is that there is now a single method to create a text field with a label instead of two. And under the hood, we generate both those input and label tags, and we link them correctly so that that Axe rule 4.4 is satisfied 100% of the time. So what we've done here, in effect, is we basically made that Axe error, I would say, basically impossible to violate if you're using this tool. And while it's not possible to automate our way out of every possible accessibility violation, it's nice to know that this rule 4.4 really isn't going to be an issue for our customers anymore. So what this work has taught us is that beyond these accessibility scanners, that focusing on accessibility has helped us to decide what components we should really build, because we need to focus around what abstractions can actually enable accessibility. So one good example of this is that in our design system we have an avatar component. This is all over our application. I think we have 100 unique places that we use an avatar or something like that. This avatar often links to a user's profile page. You have probably seen it in a timeline, for example. And the problem is that we tend to use this avatar component next to a text link that is also to the user's profile. And sometimes we would use a hover card on these, sometimes for both the avatar and for the link. And this combination can result in the user's name being read out loud multiple times when a screen reader browses the page. This isn't ideal. It was a common complaint. You can imagine if you're going through a list of users and every time it was reading out the name 3 times, that could get really frustrating. So in order to make this common pattern accessible, we basically extracted a UI component around it. So we call this our nameplate component, and it contains both an avatar and a text link. And then we made sure that this combination worked perfectly for screen reader users. So the last tool I'm going to talk about is called preview-driven development. So how many people here are familiar with action mailer previews? Okay, so about half. So basically, action mailer previews are a local development tool. I don't believe you really use them in production, where you can develop and test your HTML emails in a local browser. It's nice, it's isolated. So what we realized is that when we build our UI components, we should be able to write previews for them too. So a preview is just an example of a component being rendered in a specific state. So in this case, what we call a danger button. So in their simplest form, UI previews look a lot like mailer previews, which themselves are kind of controllers, kind of not. So in this case, here's a preview for rendering that. This is the code actually for what I just showed. This is rendering our danger button, and it looks a lot like a controller. So for a button component, we might have a preview for each color scheme option, as well as maybe some different functional modes. Those are just defined by adding more methods to that preview class. We also use these previews in our tests. So we wrote a render preview helper, which renders that preview code inside our component unit tests. And what that does is it bypasses the browser and creates capybara nodes for the rendered result, and then we can just assert against those. So these tests are really, really fast. And then for a system test, if we need to like click on stuff, we just call visit preview instead of render preview. So what's been really fascinating about this workflow is how much it started to blur the lines between what is development and what is test. Probably a good talk for another day. So what we've ended up doing is that we've started to consolidate all of our test cases into previews. We write a preview while designing our components, then use render preview or visit preview on our tests. And we've seen a ton of benefits from this workflow. It makes UI tests easier to debug, since you can often just look at the preview and see what was broken. You don't need to boot up the app in some complex state, right? So going back to the test of the button, if I misspell the selector in the test, it's going to fail, right? Instead of trying to boot, the test in a browser, or dig through the rendered HTML, I can just navigate to the preview and inspect the state in Chrome and see that the class is incorrect. What's also great is that these previews make a lot of our UI components discoverable. So at our scale, we have thousands of components. I think we have 2,000 components in our application. It's really easy for 2 teams to end up, or maybe even 3, to end up building the same thing and not know it. So what we do is we use this tool called Lookbook, which is very similar to Storybook, to organize our previews into a component directory of sorts that can be browsed in local development. As an aside, I don't have this in my notes here. This tool works for Rails partials as well, too. So you can use this even if you aren't using Vue component. This tool is really similar to Storybook in React, but it's been built from the ground up for Rails using Hotwire. There is a way to use Storybook with Rails, but it's a bit of a hack, so this is better. But what's great is that conceptually, this starts to couple the tests that we write to the documentation developers then have access to. This gives us an incentive to write test cases that exercise our UI in practical ways because they become the examples that we share with others. One side effect of this is that we used to actually have a separate documentation website that was somewhat manually created for all of our components and UI elements, and we actually have gotten rid of it, and we just use this instead. I don't think it's public yet. Our design system has this publicly available, so if you go to the Primer website, you can see our lookbook for all of our kind of design system components, but we're looking at doing the same actually for all of the components we use for GitHub itself. So you could see all of our internal components as well. But I think the most important thing is that this workflow leads developers towards running their components through X because we've added it to our lookbook configuration. So when we build our components in isolation, we now get live accessibility feedback by going to the accessibility tab that we've added in Lookbook. What's also nice is that when we write these previews, you're actually able to get the list of them by introspecting Lookbook, and we just literally look at the list, and we have a job that runs through all of them, and Axe scans them in CI. So this is maybe a little bit dry and in the weeds, but this workflow that I kind of just described here was one of the reasons why a lot of people at GitHub wanted to adopt React wholesale, which is something that we're still going to do in bits and pieces, but this is a great example of how we can take, how the Rails ecosystem can really benefit from adapting ideas from other languages and frameworks without, requiring us to rewrite our whole front end. So in the accessibility practice, there's a term called universal design. And universal design is the idea that accessibility accommodations don't just benefit people with disabilities, they benefit everyone. In the real world, a great example of this is curb cuts. While originally intended for wheelchair users, they also benefit people pushing strollers. And honestly, I think that we don't have to lift our feet up as high when we go over a curb now as just regular people. And I think we can learn a lot from this mindset. What might universal design look like in software? One great example of this is single sign-on. Single sign-on allows people with disabilities to avoid CAPTCHAs, which are notoriously inaccessible. before I went through the experience I went through, I had never even used sign in with Apple before or sign in with Google. And once I realized that I didn't have to click on buses anymore if I used one of these buttons, I started using it all the time. But perhaps the bigger lesson here is that the examples and tools I've shared today are just like part of a larger class of blind spots that we have as typically able, wealthy, typically first world software developers. And this reminds me of a quote from Donald Rumsfeld, maybe the most famous thing he ever said, which is that we know there are known unknowns. That is to say, we know there are some things we do not know. But there are also unknown unknowns, the ones we don't know. And if one looks through history, it is the latter category that tends to be the difficult ones. Applying this way of thinking has opened my mind to other similar problems. Take browser performance, for example. At GitHub and many companies, we are issued really powerful Apple laptops. I think my laptop has like 64 gigs of RAM on it. And we're given the latest cell phone for security reasons. And these things enable us to be about as productive as a computer could help us be. But they give us a false sense of reality. Even among our customer base at GitHub that skews towards users of more powerful hardware, the experience we have using our products is not the same as our customers. In just one example benchmark, this was from late 2021, this is the phone that GitHub users were issued, which is the iPhone 13 Pro. The next fastest Android phone was, what factor is that, 3 times slower in JS performance? That's the fastest phone you could buy as an Android phone, and it's significantly slower than an iPhone. A similar issue exists with request latency. Most of GitHub traffic is served from the Virginia region, we'll call it, which means that our majority US staff does not experience the request latency that people from around the world experience. Especially, I've heard it's been pretty bad in Australia. So how do we look out for these blind spots? How do we find unknown unknowns? We can do it by embedding empathy into our engineering practices. And it really starts by putting yourself in the shoes of others. The more different from yours, the better. Thank you. That's our neighborhood now. It's coming together. Yeah. I have some time for questions. So the question is anything that I've shown open sourced? I really should have included a link. The forms work is all in the primer view components Ruby gem. So you can see it there. The Axe custom rules you mentioned, yes, actually, as of like a couple weeks ago, I think it's Axe GitHub /Axe GitHub is the owner and repository. Primer, it's github.com/primer/view components. View_components, yeah. So the question was, how quickly do you get feedback in CI for the accessibility tests? It depends on which tests they are, because some of them can be run statically, right? So we have a bunch of ERB linters, and that's actually another link to plug. We have ERB lint GitHub. If you go to the GitHub org on GitHub and search for ERB lint, you can see our accessibility ERB linters, and those are really, really fast. That's where it gets tricky, right? Because then you're starting to talk about browser-based testing, which is notoriously fraught and slow. So it's basically how fast can you run browser tests. And I will say that as a bit of a JavaScript skeptic, Playwright is awesome, and I will go on the record in saying that I like writing Playwright tests and find them to be way more reliable than the Capybara stack at this point. That's kind of like a bit of a transition we're going through at GitHub, is starting to move all of our UI testing to the JS stack. There's just so much more focus happening on tooling there than in the Rails space. I find that those tests run significantly faster than Capybara tests. They're less flaky, and they make better use of the resources of the machine they're running on. Yeah, the question was, is GitHub implementing any colorblind friendly options? It's helpful to hear you ask that question, because the team I was working on a couple months ago shipped that 6 months ago. But the fact that you are asking makes me realize that we might not have publicized that enough. So if you go into settings appearance or settings accessibility, I think is where it is now. There's a couple different color themes. It's where you can turn dark mode on or configure dark mode. There's a couple high contrast options and I think there are 2 different colorblind themes. So the question was thoughts on using AI tools to caption images.
Not caption, just to check.
Oh, to check the captions. I think someone on the accessibility team did some experimentation around that. The thing that's tricky for us is that we don't actually have a lot of images. It's kind of the paradox is that GitHub is a lot of user-generated content. Like, you guys create as much UI on GitHub as I do as a UI engineer because you're the ones writing things in Markdown and putting HTML on GitHub pages, right? So like, we've toyed with the idea of providing more feedback. I think we're, like Slack and Twitter now will at least prompt you to put an alt tag on your images. I think we're starting to look at doing something similar, and it would be really cool to check those with AI. I would kind of assume that if you're prompting someone, they'll do a good job. I could imagine that being tricky feedback to provide, right? Like, this doesn't look like a dog. This looks like a cat, right? Like, that isn't a sandwich, right? Yeah. I would say that, so the question was, what caused GitHub to invest in accessibility? Oh man, there's not a lot I'm allowed to tell you, unfortunately, on that one. But there are reasons why we invested in accessibility. What can I say? Legal pressure. Yeah, and I think that that's the thing that like comes up in every accessibility talk. Just know that we've faced legal pressure. If you haven't, you will. So the best thing you can do is to start to do some of the stuff I talked about. I think that like, I can speak plainly about it, that one of the reasons why I would encourage you all to go out and adopt Axe in your applications today is you can imagine if an automated tool can tell you your app is inaccessible, it makes you a pretty easy target, right? Like if a bystander can just be like, I ran this free tool, it took 10 seconds, and their like link contrast is 2 to 1, right? Like, it's pretty hard to say that you even tried to make your app accessible if you fail in the most basic possible way, right? So, does that answer your question? So the question is, how do you think about accessibility standards for user-produced content? So, first of all, there's a specific guideline in I don't know if it's a WCAG guideline, I think it's called APG. We had a seminar on it internally a year ago. There's a specific set of accessibility guidelines for user-created content, which basically recognize the fact that as an application owner, it's not within your control, right? Like, if you give us HTML for your GitHub Pages site, we can't really change it, so that puts us in a tricky spot. That being said, if you use like the Markdown toolbar, like when you're authoring, say, a comment on GitHub, we want you to generally make something that's accessible. So that's an example of where, like, when you're inserting an image, I think we already have changed it so it prompts you to put in some alt text, or at least puts in placeholder alt text. That's an example of something you can do, is if you have authoring tools, you can nudge people towards accessible practices. But at the end of the day, if you allow HTML in your input and someone pastes in HTML, I know you're off the hook from like a legal standpoint, generally. Don't quote me on that, I'm not a lawyer. But it's incredibly difficult, and that's why, like, if you're creating an authoring tool that actually creates things that are accessible is incredibly difficult, but it's really important work. I will say that, like, our goal at GitHub right now is just to make the whole app be usable for someone with a screen reader, like across all those 2,000 pages. That's only the first step in our journey. Our goal after that is to start to become a leader and then an innovator in the space where, like, we can say, okay, this experience is not just, it doesn't just work for someone who has disabilities, but it is like, it makes them maybe even more productive than someone who isn't impaired. The question is, why are we migrating to React? One of my colleagues is smiling at me right now. Well, that's a different talk, right? I think that, gosh, that could be a whole talk. I think the thing that would be the most interesting answer to you would actually be hiring, which is that we're 2,000 engineers and you want to build 350 new controllers a year of UI. Are you going to be able to find enough people to build the UI? And we're finding that a lot more people in the industry, because React is kind of the front end no matter the back end, the population of React engineers out there is just much larger. That actually is one of the driving factors in us using more React. The other thing is like really complex UIs. Like we recently redid GitHub projects in React, and we have people at GitHub who are really into web components, do an amazing job, industry leaders, like literally working with the folks at Google and the folks at Mozilla to like develop the web component standard. And even they recognize that like something as complex as the new GitHub projects would be very difficult to build with web components. So there are certain complex things that kind of fall over when you try to build them without React. That being said, 97% of GitHub is still in the Rails server rendered stack. I can't imagine that will go below 90% in the next couple of years. I mean, I think that the question is accessibility for APIs. I know that it has not come up. So my kind of position is that I am helping GitHub navigate this kind of work across all of our user UI architecture. And the question of UI stuff hasn't come up. Docs certainly have, making sure that they pass Axe. Axe is actually really great for something like a documentation site because it's static content. The problem with Axe is that as you get into things that are more dynamic, you would literally have to run Axe on every permutation of every possible state of your page, and that's where things get really weird. The question is are we complying, are we targeting AA or AAA? I believe we're doing AA right now, but the goal is to do AAA. Yeah. Any other questions? Wow, that was a lot. Thank you, guys.